Hello to everyone out there watching. For those of you who don't know, my name is Joe Toscano. Previously was an experience design consultant for RGA and oversaw the product ecosystem at Google. What I'm going to walk you through today, though, is the new work that I've been working on, which is Designing Intelligence, a book about designing automation, artificial intelligence, and in general, the future of interaction models, which is conversation. Uh, So what this talk is about, it's about design thinking for the ambient era of computing. And what exactly does that mean? Well, that's us talking about when these machines have data flowing through them, there's artificial intelligence underlying all of their actions. There's going to be a lot of work done for us, and we will navigate it in different ways than we currently are today with graphical and gestural interactions. Those will still stick around, but there will be definitely a new model with voice and conversation, and it'll be an interesting world that we play in. But before we get started, I want to walk through a little bit of history, because I believe that if we don't know why we've gotten to the place that we are, we can't truly innovate and create things. So we're going to start off with data, technology, and evolution, how data has helped us evolve over time. Realistically, for most of you who haven't abstracted it quite this far, data is just information that's received by some device, some sensing organ, in order to collect and reference for later. So this could be as simple as conversation exchange between you and a friend. It could be as complex as a database that's on a server somewhere. But data has been around for the entirety of human history and has been a large part of why we've evolved. So if we think about it from a historic perspective, we started exchanging data one-to-one as human beings, maybe small tribes, small groups of people. But in general, when we're talking to these people, we knew them. The context was high, right? So we maybe had stories that only we knew between each other, things like that. The specificity right there, so the context is very high, but the reach of our message, the speed of dissemination are all pretty low, right, comparatively. So this took us generations to evolve because we had to evolve through storytelling. We taught each other, we learned over time, we passed down through generations. It took us millions of years to create a sharp tool and fire and things that we consider to be incredibly simple, right, because of this. As we progressed and evolved, we grew into towns and communities, villages. You may have a greater reach at this point. You may have a little bit more permanence into your message, like there may be signs that are put up on the walls. There may be commandments that are written down, things like that, right? But in general, it's not too much better. Where we really see some progress, though, is when we hit the Gutenberg press. The Gutenberg press is something a lot of people don't think about, but it is the first printing press. And what that enabled is it enabled permanence of information to skyrocket. So if we wanted to make a book previously, we'd have to write every single copy of that book. Now, we're capable of writing one copy of the book and replicating it as many times as we want at scale. So what this does is it allows, like I said, information to be more permanent. We can begin to organize it better, but you still have geographic limitations in terms of shipping the book and getting it around the world. You have language constraints with people who can't understand your language, or people who aren't even literate at this point in time, right? However, we're also seeing that the context of the information is going down as well, because when we create something that is more permanent and anyone can go find, it doesn't have the context that it does between us speaking to someone we know, right? So that's important because at this point now we're evolving faster and faster. Information is more accessible, it's more permanent. I can go back 300 years and read someone's thoughts, and we evolved. And also information control. They printed a Bible, right? This took the information out of the church, which is something that most people don't think about as well. But when we took that information control out of the hands of the church, then we saw world wars because people were able to form their own opinion about religion. They didn't have to go to church to read the Bible or whatever it is that they're reading. So information is powerful. It does help us evolve. It's changed us a lot over time. Once we get into the telecom era, now we're reaching around the globe. Our reach is almost limitless at this point. Things are moving at the speed of light. But we have constraints as to, who has a TV in their home, who has a telephone, who has any of these services, right? Context continues to plummet because now information can be accessed from anywhere around the globe. They may not even speak your language. It can be really tough. Once we hit the internet, now everything's more and more recorded, permanent, moving at the speed of light across the globe. Context of conversation, the thing that really defines how we understand this information, is at its very bottom with the internet. It's something people don't think about, but I mean, consider the fact that you can put a piece of information out on the internet, anyone can go find it, and it can be resourced for the rest of time as long as it's alive. The context, like I said, is almost invisible, but everything else, the reach, the speed, the permanence and organization, they're all through the roof with the internet. We're seeing changes, though, in the way this is working. And we look at modern era of targeting on the internet. Information can now be specified or relayed with context to specific demographics, to groups of people who we believe will be interested in this stuff. It has enabled, again, like I said, us to advance even farther and quicker, because now we don't have to waste as much time and money pushing to people who don't care about our message or who won't even be able to understand it. And with automation and conversational agents, we're reaching a point where we will be able to scale ourselves. The one-to-one interaction that we had historically millions of years ago is now going to be reached at scale, and we're going to see ourselves evolve at a rate that we've never understood before. And why is this? Well, there's these four main points, which are the reach of the information, the specificity, the context of the information, the permanence and organization of the information, and the speed of dissemination. And if you look at this over time, you can see that context started very high, right? We were having one-to-one interactions, and over time it starts to drop down, it plummets and hits the bottom, like I said, with the age of the internet. Everything else, though, the permanence is something that started really low. With conversation, it's stored in our head, and we can only remember so much, and it's so organized, right? With books, with the Gutenberg press that picked up, with the internet, telecommunications, and digital, it's only getting more and more. Speed is getting faster, reach is getting wider. We are reaching this optimal point of all of these things evolving together and helping us speed up as well. So if you look at societal evolution, you can see that hundreds or millions and millions of years went by. We were in the hunter-gatherer era, right? It took us, like I said, hundreds of thousands of years to evolve, to create fire, to sharp tools. Then we get into a new paradigm millions of years later, which is the agrarian era, where we're farming for sustenance, and that lasted about 8,000 years. But then we get into the industrial era, and that's only lasted about 240, which is where we are right now. So consider here the paradigms are shifting dramatically. We've gone from millions of years to thousands of years to hundreds. But then we look at evolution within the industrial era. We hit the steam engine era, where we are now accelerating our mechanical abilities beyond anything that humans could possibly do before. We're moving faster, we're lifting heavier weights, we're moving farther. Electricity allows us to disseminate ourselves and have reach across countries in the globe without having to be sourced by water, right? And then the computing era, what we're into now, we're accelerating our cognitive abilities the same way the steam engine accelerated our physical capabilities. Dive into the computing era, though, and again, we see paradigm shifts. We've gone from the personal computing era, where we have mainframes and desktop computers, which for the mainstream, the mainstream lasted about 25 years. We hit mobile computing about 10 years ago with the iPhone. We're into gestural interactions and whatnot, but now we're entering this era where in IoT and everything being connected to the internet, where we're entering an ambient era of computing, where things will work in the background and do the work for us, and we will steer it through gestural interactions, through visual cues, but mostly through conversation. And then this is an example. This is industrial social development over time. If we look at a quick history of automation, though, you can see that we've made a lot of progress in a very short amount of time. The 1800s and 1780 area, the cotton gin was created. And then 1998, we had Google search, right? In less than 200 years, we went from the cotton gin to Google search, which is pretty crazy to think about. It's a lot of growth, a lot of acceleration. But if you look at modern automation, we reached this point of things that we're speaking to, things that can drive us around, things that are monitoring the world around us, and even with Boston Dynamics, machines that are replicating human equilibrium. Why did we hit this, or why are we moving so fast? Well, we talked about mass data collection already and what impact data has on this. Then we have to talk about processing power, storage capacity, and lastly, algorithmic efficiency. So when we come into this, processing power, storage capacity has to do with Gordon Moore, co-founder of Intel, created or set Moore's law, right, which was created Electronics magazine, 1965. Essentially, he said back then that the power of computing is going to double every year or two for the next 10 years. What he didn't realize is that it would go on for the next 50. So we've seen, instead of just a couple doublings, we've seen more than 25 doublings, which has us growing exponentially. We've seen chips with less than 1,000 transistors to now chips with 7.2 billion transistors. It's pretty crazy. And to add to that, we also have the law of accelerating returns by Ray Kurzweil, which speaks about how when we become more organized, time shrinks, so we speed up. And this is happening in terms of algorithmic efficiency. The better we can organize things, the more meaningful we can make these relationships and contextual we can define things, the more we will accelerate ourselves. So AI is the new electricity, and data is the new oil. The next step is to talk about, well, then why is conversation such a big player in this new field, this new era? And to understand that, let's talk about history of computing interaction models. We started out mainframe computers, 1890s with the census calculator. It's binary, it's punch cards. This lasted a long time. 1960s and 70s, we start to get into assembly languages, command line. It's a little bit simpler, but it's still very technical, and most people don't pick it up. Because at this point, we're still learning a computer's language. We don't even pick up Spanish and French and other languages that we don't, aren't our main language very well. So what's going to make us want to pick up a computer? Then we talk about how, late 70s, early 80s, we get into the graphical computing era. This is where we see a mainstream audience spawn. That's because we're not learning a language of a system. We're just learning the system. And even a toddler can point and scream at what they want, Next, we talk about the mobile computing era, which we hit, and we're getting into touch and gestural interactions. These are pretty good for people who are born into technology, people who are very familiar with technologies and comfortable with playing around. But for older generations, this is very difficult. There are no signifiers and affordances of what to do and how to do it. So we've lost a lot of people with these, actually. The reason why voice and conversation is going to be the next model of human-computer interactions is because it's the most intuitive interface possible. All you have to do is know how to speak a language, and the machine starts to work. It's the first time in the history of human-computer interaction models that we don't have to learn a language, we don't have to learn a system. The system's learning us. And essentially, it's the closest thing we have to being plugged into a computer, because all we have to do is speak. So this will happen, and things are getting much better very quickly. We're just in the early days of it. But if you look at the statistics behind this, 2015, 20% of Google search was through voice, and 12% of that year were just people that started that year. So 12% year over year is pretty great to see it. And then if you think about also queries, how people actually use Google search, just recently, it was reported that over 75% of search results were in natural language queries, which means that people aren't commanding Google anymore. They're not saying, find food near me, or like find food Denver, Colorado. They'll say, what can I get to eat that's around me? They'll say simple things that we would say as if we're speaking to another person, and they type it into Google command line or into Google search. So people are ready for this. It's coming. It's definitely going to be a big player in the future. And then lastly, what I'd like to talk about a little bit is the future and where this can go. Because if we don't think about the implications of this, then we can't really create great systems. First, it can be safer, more accessible, and more meaningful. In terms of safety, if we look at Tesla, people are scared of self-driving cars, but if you really consider the facts, Tesla, it's machine vision, or it's a machine learning knowledge that is crowdsourced. So in 15 years, Tesla has accumulated more than 3,000 times more driving experience than you will ever have in your entire lifetime of driving. 3 billion miles compared to what the average human being is about 1 million in their entire lifetime they'll be lucky to get. So safety is a thing. Like with machines and crowdsourced knowledge, we will create much safer systems. Not only Tesla, but we see this in the medical field and examples as well. In terms of accessibility, this is a system by Soul Machines. It's called Nadia. They work with the New Zealand Disability Insurance System, which is typically a phone operator. They're creating this bot which not only can speak to the user, but also can monitor them with the cameras on top of the screen to see, are they getting upset? How are they dealing with this? Did they fall asleep? What's happening? And then they have a conversational agent that emotes just like a human being and can help change the environment if need be. So these machines, this voice conversation interactions will make the world more accessible. It will get more people online and give them more opportunities. And then lastly, more meaningful. I mean, if you're using conversation to steer your machines, you don't need to be glued to a screen. You can go do more things, heads-up computing, where you're interacting with people in real life. You're back to somewhat more of a traditional model, I suppose, but more meaningful life this way. And then lastly, I'll talk about what can happen if it goes wrong, though, because we're already seeing this, and automation is going to be the core foundation for a lot of things that we're building now will be around for years to come. And what's happening now is we're seeing that it's skewing our perception of the world. It's creating systemic biases because it's trying to define incredibly illogical life forms as logical, and it's cutting people out of the job market. So if we look at skewed perception, we talk about traditional media, where traditionally there's only so much that's out there. There's only so many TV channels. There's only so many newspapers in print, so many magazines. So whether you're conservative or you are progressive, there was a general bell curve to the information that was out there, and you could communicate with people in your proximity. However, while this did make journalism more appealing and ethical because there were checks, there were editors, there were doing your research and maybe putting out the article in a couple days instead of a couple hours, it also suppressed a lot of minority voices. With the modern media, we've seen that completely flipped. Anyone can be a journalist now. Anyone can be an expert now. But that doesn't mean that they've been trained to do it ethically or to do their research and source their facts. And with the attention economy forcing us to create clickbait, essentially headlines, in order to get attention and drive revenue, we're seeing very polar opposite spheres of the world being created. It's to the point where people on the opposite side just can't even communicate with each other. It's not that one side's dumb and the other one's smart, or vice versa. It's that their perception of the world is different completely. And there are statistics from NYU on how this is playing out at scale. So this gets very dangerous in terms of trying to have a formal government when the people on both sides of the issues can't even communicate. There's no formal discussions. There's no ability to do that. And this can get dangerous, very, very dangerous at scale. Next one, I'll talk about systemic biases real quick. Machines, so I talk about a very simple example from Kathy O'Neill, who wrote Weapons of Math Destruction. She asked, we're going to create a credit score algorithm, assess someone's credit worthiness. Would you ask them for their race? And typically the answer is no, right? You might get a really angry room at that point. But then you ask, well, would you ask them for their zip code or for any information about where they live? And typically you get yes, right? Because it seems like a pretty safe variable, but by knowing someone's zip code, we can very accurately get a good average of what their race is, what their income level is, how much crime is in the area, what their education level. A lot of different factors can be told by where someone lives. We can create systemic biases that then scale across these algorithms in ways that we didn't want to. We didn't intend to. The best intentions could have made it, but the best intentions can be biased. And that can really hurt the world, considering a credit score then goes on to the ability to get a job, the ability to get a loan for your home or for education, get good health insurance rates, a lot of different things, right? So variables need to be considered. Teams need to be built diversely, and we need to think of things beyond just a purely engineered perspective. And then lastly, I'll talk about jobs before we take off. If you look at the job market from the 90s to 1995 to 2011, in the United States. This is just in the United States, but if you look at the market here, you can see that in the 90s, the GDP was pretty steady. late 90s, early 2000s, we had the dot-com bubble burst, and both of them crashed. However, both of them recovered. And then in the early 2000s, you see that technology has accelerated our GDP. Sure, there is outsourcing. That's definitely a factor. But it is not purely outsourcing. People remain in their jobs, but GDP skyrockets. There's something else going on, and that is the beginning, what we see in the early 2000s, of automation and computers starting to do the work. However, people keep their jobs because as an employer, whether you are super cynical and narcissist or not, it hurts you to lay off that many people. It hurts your soul a little bit. And even if you're just a terrible person, like bad PR, you don't want it, so you won't let them go. But then we have the Great Recession, and we see both of them crash, right? The GDP and the employment. And what happens here is now those employers who saw this coming and knew these computers could do the work have a reason to say, hey, we just can't keep you around. We have to let you go. And post-recession, we see that the GDP, it does indeed recover, but the employment does not. And that's going to be a trend for years to come. That's not just now, that's for years to come. So something to think about, some things to think about while you're building these things is think about the impact you're creating, help people bridge the gap. You may be making a lot of money on this, and that's great. I want people to make cool products. I want things to really have a great impact on the world, but just understand the impact you are making on the world and be mindful and help educate people. So it looks like I got to take off. That's the end of my talk. But thank you all for listening, and see you around.